Hello geometry friends. Today we are going to learn what happens when two lines, line L and line K, are cut by a transversal line T. So as we see, when that transversal slices through two different lines, it creates two intersection points. We'll call these neighborhoods. In this case, we have an upstairs neighborhood and a downstairs neighborhood. When we look at pairs of angles, we are going to take an angle from each neighborhood. Our first pair of angle is called corresponding. Corresponding literally means same position. So in my top neighborhood, I look at angle 1, it's in the upper left. That is in the same position as angle 5. So we can say that angle 1 and angle 5 are corresponding. What might be another one? Well, let's see. Angle 2 is in the upper right, and angle 6 is in the upper right. So those would also be corresponding. Angle 3 bottom left, angle 7 bottom left, another pair of corresponding. And finally, what would our last pair be? You got it, angle 4 and angle 8. When we look at our neighborhoods, we notice that there's an inside between the two lines. We'll call that the interior. And there's an outside, exterior on top, exterior on bottom. Our next pair is called alternate interior. So we're looking inside the lines. Now, alternate doesn't mean it's on the same side, but rather alternating sides of our transversal. So for example, angle 3 and angle 6. What would be another pair? You got it, angle 4 and angle 5. Well, if we have alternate interior, we probably also have alternate exterior. So now we're looking outside of our lines on alternating sides of the transversal. So for example, angle 1 and angle 8 and angle 2 and angle 7. Not bad. Finally, we can be on the same side of our transversal. So if I look inside my lines, interior, on the same side I have angle 3 and angle 5, and also angle 4 and angle 6. Same side exterior, I think you got the hang of it. Angle 1 and angle 7 and angle 2 and angle 8. Great work, everyone. Now let's try some sample problems. If we look at this case, we have our two lines, L and K, cut by our transversal T. So now the interior is here, and the exterior would be here. If we look at angle 10 and angle 11, are they inside or outside? They are inside, so we could call those interior, and they're on different sides, so we'll call them alternate interior angles. For number 2, we have angle 8 and angle 14. First, we want to decide, are they inside or outside? Looks like they are exterior, but instead they are on the same side. Same side, exterior it is. Couple more. 7 and 11. Now this one's a little tricky. They're not both inside or outside, which gives us a clue that this must be our other kind. So 7 and 11 looks like they're in the same position. Do you remember what we call same position? That's right, corresponding. Couple more, angle 11 and 14. What's up with that? Well, they're not one from each neighborhood. Let's go back to what we already know. Angle 11 and 14, vertical angles. I thought I could trick you, but clearly not. Okay, two more. Angle 8 and angle 13. They're outside the lines, so exterior, on different sides, we'll call that alternate exterior. And finally, 9 and 11, they're both inside, so interior, and they're on the same side. Same side interior. I hope that you've enjoyed this little exploration of angles and lines. Have a great day, geometry friends.